Alright, this is your quiz review. Number 1, this is on quadratics, so please know how to identify the features, the transformations, domain and range, and solving. So let's go ahead and look at number 1, and this is identify its features. You can use Desmos to graph this equation here, but it's down below, and all you really have to do is just look at the graph that's given to you and find the features and identify the transformation from the parent function. So first let's go and identify the features. So vertex. Vertex is your turning point. So it's where the parabola stops increasing and starts decreasing. So the top or the bottom of a parabola, the lowest point or the highest point, is always the vertex. It's with a point in the middle. So the vertex here is 6, 2. Now the axis of symmetry, the AOS, the axis of symmetry is a vertical line that splits this parabola in half, therefore it's also in the middle, and the relationship between the axis of symmetry and the vertex is that the axis of symmetry, or the line of symmetry, goes straight, runs straight through that point, that vertex point. So it's going to be the x in your vertex, x equal to 6. So if I were to graph the axis of symmetry, it's this dotted line that's imaginary that's showing you the line that splits your parabola into two symmetrical halves. Alright, now the x-intercepts. The x-intercepts are located on the x-axis. And in this case, we have 2 x-intercepts, here and here, and this is the x-axis. So I go along the x-axis and see where this parabola crosses that x-axis, and it crosses it at 4, 0 and at 8, 0. So 4, 5, 6, 7, 8, 9, 10, if we number 3, 2, 1. Alright, so it's 4, 0 and 8, 0 are my x-intercepts. Now if I were to ask for zeros, then it's a list of my x-intercepts in brackets. It's a list of my x-intercepts in brackets. I'm never really that perfect on doing those little braces, the little brackets. Alright, the y-intercept, Okay, y-intercept, instead of crossing the x-axis, is now crossing the y-axis, and this parabola crosses the y-axis right here at negative 16. So my y-intercept is 0, negative 16. Alright, now we get into, and that's all you have to do. If you can go ahead and identify the vertex, axis of symmetry, x-intercepts, y-intercept, and this is a maximum because it's your highest point. It's your highest point. A minimum would be your lowest point. That's if your graph was in this shape right here and you're opening upward, then that point right there would be a minimum. Again, that would be your vertex point, because now the parabola is no longer decreasing, it's increasing, and that would be a minimum. Okay, because it's your lowest point on this graph. This is the highest it reaches on this graph, so that's why it's the maximum point. Alright, now let's go ahead and look into the transformations for this. Alright, you're always comparing to the transformation from the parent function. So if I were to graph the parent function here, it would be here it would be to this graph right here. Okay, so this is the parent function of a parabola. This is what I have here. you can already tell that this is a wider graph, right? This is a wider parabola, and it's because it's due to your A, okay? So let's examine our equation right here, okay? Do we have a reflection? Of course we do. You can see that. It's going, the original is upward, now it's going downward, but it's also because the reason why it opens down is because A is negative. This front number is negative. So is it reflected? Yes, there is a reflection. Now, do I have a stretch or compression? Stretch means skinny, compression means wide, and because my A, 1/2, is less than 1, then yes, it got wider, okay? So, by the way, the equation for the, if you're looking this in Desmos and you want to compare the two visually, it's always to the parent function y equals x squared, but I will be giving that to you in the problem. So if you want to graph both of these in Desmos and see for yourself that one's wider than the other, then you can do that, okay? So is it wider? Yes. And because A is less than 1, so that 1/2 is less than 1, therefore you have a compression. A reflection because you have a negative 1/2. It's because of this negative here. That's why you have a reflection over the x-axis. Now, is there a horizontal shift? That means, does it go from left, does it move left or does it move right? And yes, it moves right, and you can see it moves right 6 units. That's right here. That right there, that's your H. Your H is 6. So yeah, it moves right 6 units. So it's shifted right 6 units. Now, is there a vertical shift? Yes, there is a vertical shift because it came from 0, 0 to here to 6, 0, and then it went up to 6, 2. So it went up to, and that's right here, the last number here. That's your K. Your K is 2. So it went up to, and A here is negative 1/2. All right, so K, it went up. There was a vertical shift up 2 units. All right, so that's all I'm looking for in number 1 from you, is to identify its features. These features here, make sure you know the difference between minimum and maximum, and that the zeros are the same thing as your x-intercepts. And please know the reflection, left, right, and upward movement given your equation. All right, let's go ahead and look at number 2. So number 2, we have x squared minus 2x minus 9, and it says use Desmos. So I'm expecting you to use Desmos. So I'm going to go ahead and look in Desmos really quickly. Desmos. X squared minus 2x minus 9. Do not, and I repeat, please do not put equal 0 in there. Do not put equal 0 in there, okay? But go ahead and you do need to put the y equals in the front. Y equals. So now it's wanting me to solve this. Now understand that the solutions to a quadratic equation are my zeros, which are the same thing as my x-intercepts. So I'm going to go ahead and look for my x-intercepts, and the reason why I tell you to use Desmos is because you can easily just click on the x-intercepts here, and my answer is negative 2.16 and 4.16. So negative 2.16 and 4.16. So that's all I'm doing is graph. This is the easiest way to solve a quadratic equation. Make sure it's equal to 0, which it is. put this in Desmos, y equals x squared minus 2x minus 9, and all you're doing is finding the x-intercepts, okay? And that it was negative 2.16 and 4.16. Nearest hundredth, so make sure that that's 2 decimal places after the decimal. So 3.9 would not be an answer, okay? All right, so that was number 2. Very, very simple. Just graph it and find my x-intercepts. All right, let's go ahead and look at number 3. All right, here's another Desmos problem. But in this case, it's not equal to 0. Do you see that? Do you see that your equation is not equal to 0 right here? So what you're going to have to do is you're going to have to equal this to 0 by subtracting 5 and adding 2n to both sides, so that this side cancels out and equals to 0. So we got n squared. Now because I subtracted 5 from 15 and I added 2n because I have a minus 2n, so I have to add 2n to this 5n, I get n squared plus 7n plus 10, and that equals 0. Now I have an equals 0. Now I can put this into Desmos. Now what I'm going to do is I'm going to change that n to an x. I'm going to change that n to an x. And it says, remember, to set the equation equal to 0 first, did that by adding and subtracting. Go ahead and use Desmos or your calculator. I showed you both ways on how to do that. We're going to put y equals x squared plus 7x plus 10 into Desmos. And again, this is it's easier to work with Desmos. It's also a free tool that you have at your house in case you don't have a calculator. All right, so this is the graph that I got when putting it in Desmos. Y equals x squared plus 7x plus 10. I'm looking for my solutions, and all I have to do is click on the x-intercepts. -5, -2. So all I have to do down here is plug in -5, plug in -2, and I'm done. No spaces when entering the number. That means no space between the negative or the 5. Okay. Now I'm going to ask you how many zeros do I have? Again, zeros are your solutions, which are your x-intercepts. I need you to know that vocabulary word 0. That is the word they're going to use in STAR. So how many zeros does this graph have when you look at it? And that's what I'm going to have is I'm going to have a bunch of graphs for you. I'm going to have 10 questions in which they're nothing but this is just give me the zeros. Just graph it and give me the zeros. Well, does this parabola ever cross the x-axis? No, it doesn't. So how many zeros do I have? 0. I have none. Okay? And you're not going to write the word none. It's going to be a drop box 0, 1, and 2. So you just select 0. It has 0 zeros. Okay? It doesn't have a solution. Now the domain. The domain for a parabola, which you have to understand, is always going to be all real numbers. The reason why is because the parabola goes forever to the left and forever to the right. So even though the graph that they provide you doesn't have an arrow, it might be a window like this, a calculator window like this. You have to know that those lines to your graph goes on forever to the right, left and forever to the right. And because I go on forever and ever and ever and ever and ever, I go forever to the negative infinity and to positive infinity. And that is all real numbers. Negative infinity to positive infinity. all real numbers. That means it can be decimals, it could be whole numbers, it could be fractions, it could be 0. So it's negative infinity all the way to positive infinity, covering all my x values. I have no gaps in this graph. Now, from left to right, that's the domain. The domain is your x. Know that. Domain is x, and x is all real numbers. Okay, now look at my range. My range is y. My range goes from top to bottom, bottom to top, right? So what is this vertex? Well, my vertex here is 0, 4. So how low did this graph go? And it went down to 4. So is it below 4? No, my graph is above 4. And it's also equal to 4. So how do we represent that in an inequality? It's y is greater than or equal to 4. That's where my graph is. My graph covers all the y values from 4 to positive infinity. Okay.